Hey everybody, Mr. Bremberger back. I want to talk to you today about some sex-linked traits. Now, anything that's sex-linked is going to be linked to those sex chromosomes that we get from our parents to make us, either male or female. So again, we're coming back to this karyotype that we looked at in the original heredity video. Again, here we have 26 chromosomes, or actually in this, totally wrong number, sorry about that. We have actually 47 chromosomes in this person's karyotype. Remember with the extra one there on chromosome number, or pair number 21. This female, again, is going to be representing 2 of those X chromosomes. Now remember, we're going to have a Y chromosome at chromosome pair number 23. We're going to have a male. Now, some interesting facts on the Y chromosome that I have actually found for you is that, we need to recall that the Y chromosome is a little bit smaller than the X, which, as a result, that Y chromosome is actually only going to contain about 26 different genes. All right, 9 of those 26 genes are going to be responsible for the production of sperm. So that's actually quite a few different genes in play that are responsible for one major process, and that would be obviously reproduction. Only one of those genes, one of the 26 total genes, is responsible for anatomical traits, all right, or the parts that make you a male. That gene in particular is known as the SRY gene. And there's some interesting studies that have been done on it, and if you want to take a look at those, feel free to let me know and I'll direct you, especially if you get to that extension menu. I'd love to, obviously, give you some insights on where to go to investigate that particular gene. But kind of backing up to that sperm production, if you have a problem with any of those 9 genes, that could lead to infertility or the inability for you to produce offspring. So just some interesting facts on the Y chromosome there. So sex linkage. All right, these are going to be only the traits that are going to be linked to your X or Y chromosomes, and most of which are going to deal with the X in particular. All right, so again, if you want to recap on how you get your chromosomes, you can take a look at this right here. But for the duration of the sex-linked trait talk, I want to talk specifically about a disorder that can be X or sex-linked in this case. And that is the disorder of red-green color blindness. All right, this is an X-linked recessive trait, which means that it's only found on the X chromosome and that it can only be expressed if you have a recessive condition or the recessive trait. So in front of you right here, we have a female that would be referred to as a carrier in this case. This female is not going to exhibit any red-green color blindness, although she does pass the recessive trait along with her, or have the ability to pass it on to her children. That being a 50-50 chance. The person that, the male in this case, has the dominant allele for red-green color blindness, which we are illustrating here with the capital B. So if we look at the progeny here, or the individuals or the possible offspring, obviously we get a 50-50 chance on whether we're going to have a male or a female. So your females are up across the top, and we've got a 50-50 chance at producing a carrier for this particular color blindness factor. And also, if we have a male produced from these 2 people, we're going to have about a 50-50 shot of having a male that's colorblind because of this X linkage. All right, it kind of stinks in this case, because if you're a female, you have the ability to mask that recessive trait with the dominant one. So, if you think about it, how could you ever, or is it even possible to get a colorblind female? Jot that down in your notes, all right? produce an answer for that, because that's one that I definitely want to discuss with you. Again, can a female ever be red-green colorblind? And obviously explain your answer with respect to that. Folks, because that X chromosome is a little bit longer, it has the ability to carry more issues on it, more potential genetic disorders due to, whether it be mutations that can occur because of crossing over, or any other issues within the mitotic process. So that's kind of the explanation of sex linkage. Again, it's only going to occur on those X or Y chromosomes. So again, if you have any questions, let me know. See you next time.